In this section, we are going to explain the UMESHMOTION subroutine for thread wear simulation. As with other subroutines, we must first copy the interface of the UMESHMOTION subroutine from the documentation and paste it at the beginning of the subroutine. First, we write the name of the subroutine along with the inputs and outputs. Then we write include abaparam.inc command indicating we are using standard solver. The lines that are green and the first of which is written C are comments. Then the dimensions of the variables and parameters must be set. Some of these dimensions are in the interface default of UMESHMOTION subroutine and some have been added. For example, we added line 19 to calculate wear in the local and global coordinate system. Also, some new parameters named car length and EL-INC are defined here to change time increment. In addition, a small is a small number as defined here. Lines 26 to 44 describe the variables and parameters used in the subroutine. Be noted that nStreamLines is the number of points at thread in reference section of complete tire. NGen-LM is the number of circumstantial nodes at thread on one streamline, which is 48 in this problem. I have described completely in slides in the presentation. In this subroutine, the NCIL-LM is not supported. nRev offset is the node numbering offset on the streamline, which is 1000 in this problem. nRev offset is the node offset of reflected side of tire. JSL nodes is the matrix with predefined dimension. Its dimension is 2 by nStreamline, which is 2 by 27. In the first row of this matrix, the node numbers are on the thread edge of the axisymmetric model. The first row contains 27 components because the axisymmetric model has 14 nodes on the edge and its reflected parts have 13 uncommon nodes too. ENDISP1 is the sum of products of P gamma dot delta S in the previous increment and the ENDISP0 is for the current increment. Delta S for previous increments is stored in ENSTR-len1 and for a current increment is stored in ENSTR-len0. The common block of code enables us to store scalar variables to be used in the subsequent increments. It is equivalent to a state variable in UMAT and VUMAT subroutine. The data lvalidinc command will then specify the initial value of lvalidinc. JSL nodes are specified here. Now we come to the part where we talk about the main section of subroutine. First we said nLMS equal to nLMmax, which is equivalent to 100. Set LDebug and JType to 0. Then we call the getMode to LMCON subroutine. All the blocks used here are in accordance with the mentioned flowchart in the presentation. The inputs of this subroutine are nodes that are on the thread and we entered them in the input file. The outputs of this subroutine, get node to ln con, are the elements that are connected to these nodes. Then we set the LUSEEN_THIS parameter to 1 and enter the first if statement. Here, it is checked whether we are in the first increment of subroutine or not. Kink equal 1, K-mesh sweep equals 0. If we were, we would set LValidInc to 2, LValidSweep to 1, and LUSEENDISP to 0. If we are not in the first increment, then kink is equal to LValidInc. For example, in the first increment, LValidInc is set to 2, and in second increment, kink is equal to LValidInc. Thus, in the second increment, we will enter to else if statement. In this increment, the code will set the current value of delta s, sigma delta s, and sigma p dot gamma dot delta s to 0. In addition, it stores the previous value of these variables into a cumulative variable. We also set LValidSweep to 1, so one number is added to kink and stored in LValidInc. Because one number is added to kink, we enter to the next increment. And when we enter the next increment, we enter this part of the code again and set LValidSweep again to 1. If we enter in the new increment but have to do the calculations for the new nodes, then we will not enter this section. We get the coordinates in 3 directions stored in the array. Therefore, first we want to get the coordinates of the previous node. Initially, we specify its coordinates to 0 and check if L position equals to 1 or not. In case the L position is equal to 1, it is more difficult to find a node before that. For example, in this figure, the previous node for the node here, which is on L position 1 and its number is 4, has the node number 47,004. But in other L positions, it is enough to subtract 1,000 from the node number. For example, the previous node of 2023 is 1023. But if the node is in position 1, we have to use the equation here to find the previous node. The model presented here is to multiply the delta t by where and divided the product by char length. The value of char length is defined before and equal to 0.1. Then, if plm is greater than linc and the where is greater than 0, we calculate p new dt1 according to this relation. Then compare it with the suggested value of Abaqus. If less, change the time increment of Abaqus to the computed value. And if not, we consider the time increment of the Abaqus.